fail. All right, so we're going to go over an introduction to dilutions. We already learned how to make solutions, so this is a little bit different. The first question is, what is a dilution? All right, and remember when we talked about the orange juice scenario? It's more likely that you're going to start with a liquid and then add water to it when you're diluting something. When we made solutions, we started with a solid and then we added water to it and then made the solution from there. This is what if you already have a liquid and you need to lower the concentration, all right? So say you have concentrated orange juice and the taste is too strong, all right? So if you add water to it, you would dilute the orange juice, which makes sense. We do the same thing with chemicals. I buy concentrated 6 molar hydrochloric acid. This is pretty strong stuff, it'll burn you. So we don't want to use this in lab. Usually we want to use a lower molarity hydrochloric acid. So what we'll do is we'll actually dilute it next week in lab to the amount that we want to use. So today you get to practice this practical and dangerous lab technique. So today we'll go over the theoreticals, and then in lab we'll actually go through and give it a try. All right, so use the liquid dilution equation. So we have a new equation, all right? M1 times V1 equals M2 times V2, all right? And for this, the M stand for molarity, and the V's stand for the volumes, all right? The 1s are what you're starting out with, and then the 2s are what you're gonna end up with. So M1 is the first molarity. This is the molarity that you're given, which is also called the stock solution. So this is like if you go in the back of the lab, you pull out the bottle, you grab it, that's your stock solution. So from what we were just talking about, this would be like your 6 molar hydrochloric acid, all right? The second molarity is what we're gonna dilute it down to. So one of the ones that we usually use in lab often would be like 1 molar hydrochloric acid. All right, so we would need to dilute it down. And then the volumes are, all right, how much of this do we need to use? How much of this do we need to use? And then how much of this are we gonna get at the end? Well, you can decide how much you're gonna get at the end, just like when we were making solutions. Well, it just kind of depends. So for volume 2, this is the volume, the volumetric flask you're using. This is given in the need section, all right? So for example, we used 100 milliliter volumetric flasks last time in lab, right? So we'll probably do the same thing. Remember, these have 2 decimal places of sig figs when we're using them. So this is kind of like what you're using from your equipment or you're being told in the lab. The unknown is this one, all right? This is what we need to calculate. So if you take a look up here, we have 3 of the 4 numbers. We can just plug it in, divide, multiply, figure it out, all right? So that's kind of how you do a dilution problem. Much easier than having to figure out the molarity and the molecular mass and all that kind of stuff. These ones are pretty easy. So let's go through it. An example calculation here we have, using the calculation above, determine how many milliliters of 4.00 molar solution of hydrochloric acid, again that's from our solution, our stock solution right there, needs to be used to make 100.00 milliliters of 2 molar hydrochloric acid. So before we even do anything, if you look at this, we're going from 4 molar to 2 molar, right? We're cutting the strength in what? Yeah, we're basically just cutting it in half. Yeah? Okay, cool. All right, so let's talk about our M equation here. All right. What's our M1? Good, 4.00 molar. Now, this is the most confusing part of this. This is our variable. This is the unit, right? So this is kind of like X, and then this stands for molarity, okay? So just keep that straight, that even though we're using M a bunch of times in here, you know, it doesn't, you know, it means something slightly different. Okay, what about V1? Do we know what this is? No, this is our unknown, right? So I'm actually gonna relabel this as X, just to make it really obvious that, all right, that's what we're solving for, all right? And then M2, do we know what the M2 is going to be? Yeah, it's going to be 2.00 molar. And do we know the V2? What volume are we looking for at the end? Yeah, we're looking for 100, right? 100.00, and it's in milliliters, okay? Now, to solve the problem, what would you do? Yeah, exactly, divide by 4, right? Okay, what's gonna cancel out? Today's a colorful day. What cancels out? Yeah, the 4's over here on the left, right? The molarities cancel out. What unit are we left with? Good, milliliters. We're looking for volume, so that makes sense, right? All right, and then we just multiply it together. We get 200 divided by 4, we get 50. All right, let's talk sig figs. Looks like we have about 3 if we go with the least number, right? So 50.0 milliliters. What does that equal? It equals X, which actually equals what? Yeah, the first volume, right? The V1. All right. So that's the math for it. But like, what does this mean as far as like doing the lab? It's 50 milliliters of what? Is it 50 milliliters of 0.2 molar or I'm sorry, 2 molar or 4 molar? Yeah, this is like what we're starting with, okay? So it's saying that you would need 50 milliliters of the 4 molar HCl. You would put that into your volumetric flask, all right? So we have our volumetric flask. And then you'd put in, you know, how would we know to put it in 50 if this goes to 100? What would we need to use before we could plug it into this thing? How can we get 50 milliliters of this? What other glassware do we know? We know beakers, we know graduated cylinders, right? Which one's better for measuring? Graduated cylinder. So we would measure this in a graduated cylinder. All right, measure this in a graduated cylinder, use a funnel, pour it in here, then it would only be about half filled, right? Because this is a 100 milliliter volumetric flask. What do we fill it up to the line with? What do we do with the solutions? Yeah, water, distilled water, exactly. So we would fill it up to the line with distilled water. And if you think about it, if you have 50 milliliters of 4 molar hydrochloric acid, and then the other 50 milliliters is water, we just said we were going to cut it in half in the beginning, right? Doesn't that make sense that that would cut the molarity in half? It would go from 4 molar down to 2 molar if half of it is the concentrated and then half of it's distilled water, right? Yeah, so that's pretty much what we're doing in there.